This video is on angles of elevation and depression. One use of trigonometric ratios is to find angles of elevation and depression. The angle of elevation is the angle formed by the observer's horizontal line of sight and her line of sight looking upward. So take a look at this diagram here. So here's a person standing on the ground, and she is looking up at this flower on top of a building. So the angle of elevation is the angle that's formed by her horizontal line of sight looking at the building, and then her line of sight looking up towards the flower on the top of the building. So it's this angle right here marked in blue. The angle of depression is the angle formed by the observer's horizontal line of sight and her line of sight looking downward. So here in this diagram, we have the observer now is on top of the building and is looking down at a flower on the ground. So notice here's her horizontal line of sight, and then here's her line of sight looking downward, and that forms this blue angle here, which is called the angle of depression. Notice that in both cases, a right triangle is created. So if we know two of the distances, either the horizontal line of sight or the height of something, we can find that angle of elevation or depression. Or if we know one of the distances and that angle, we can find the other distance. To do this, we will use right triangle trigonometry. So let's take a look at a couple examples here. First one says Charlotte is standing 200 feet from the base of a tall building. If she determines that the angle of elevation from the ground to the top of the building is 57 degrees, how tall is the building? So I don't know any way to do these problems other than draw a picture. So let's go ahead and draw. So here's the ground, and here is Charlotte standing on the ground. And it doesn't give us any specifics about how high her eyes are off the ground, so we're just going to go with from where she is in general. And then we know that there is a tall building, and that's going to be this right here. And she is 200 feet from the base of the building. So let's go ahead and label that. And she is looking up at the building, the top of the building. Okay. And the angle of elevation from the ground to the top of the building is this angle right here, and that is 57 degrees. And what we want to know is how tall is the building, so I'm going to call that X. So right now you can see we have a right triangle. Okay, we know that this distance is 20 feet. That's how far she is from the base of the building. We don't know how tall the building is, but we know that the angle of elevation is 57 degrees. So we can write a trig ratio here. Notice that in relation to 57 degrees, 200 is adjacent and X is opposite. Adjacent and opposite are the tangent ratio. So I can say the tangent of 57 is equal to the opposite, which is X, over the adjacent, which is 200. Now, solving that for X, I'll multiply both sides by 200. So X is equal to 200 times the tangent of 57. Here I grab my calculator, making sure I'm in degree mode, and enter 200 times the tangent of 57, and that gives me that X is approximately 308 feet. So the height of the building is approximately 308 feet. So let's take a look at this example here. Clara is standing on the top of a vertical cliff and spots her house in the adjacent valley at an angle of depression of 12 degrees. If the cliff is 60 feet tall, how far is her house from the base of the cliff? So let's go ahead and draw this. I think I'll start with the ground. And here is the cliff that Clara is standing on. I'll give her a little place to stand here. And down here is her house. And of course, artwork doesn't matter. And she is looking down at her house. Okay. Now what a lot of people like to do is go ahead and draw this angle right here as the angle of depression, because true, she is looking down. But remember, the angle of depression is the angle that's formed by her looking down, but then also her horizontal line of sight. So it's actually going to be this angle right here, which is going to be 12 degrees. Now notice we probably want to go ahead and draw the triangle here to her house. So this makes a right angle. But notice what we've basically drawn is a rectangle. So I also know that this angle down here is 12 degrees because if her horizontal line of sight is parallel to the ground, then those are parallel lines cut by this transversal, and those are alternate interiors. So there's a couple different ways I could do it. I could either work on this triangle up here, or I could work on this triangle down here, knowing that they are congruent triangles. So we said the cliff was 60 feet tall, which is this distance here. It's also this distance here. And we need to know how far is her house from the base of the hill, so that would be this distance here. That would be x feet, but then this is also x feet. So whichever triangle we use, notice that in relation to 12, I have an adjacent and I have an opposite. Or if I were looking at this 12, I would have an adjacent and an opposite. So that means I'm going to use the tangent ratio. Tangent of 12 degrees is opposite over adjacent. And this one's a little trickier to solve for x. I need to multiply both sides by x and divide both sides by the tangent of 12. And then I grab my calculator and I do 60 divided by the tangent of 12, which gives me approximately 282 feet. So her house is approximately 282 feet from the base of the cliff. So in this video, we took a look at angles of elevation and depression and how to use trigonometric ratios to solve those sorts of problems.